Okay, so hopefully you solve that problem on a piece of paper or whiteboard or whatever you have. But imagine I had 6 grapes and I ate them 4 times. So a repeated addition sentence, hopefully you wrote something like this. My phone is making noise. So 6 plus 6 plus 6 plus 6, because I ate 6 grapes at a time, but I repeated that 4 times. So back to third grade, a repeated addition sentence. If I add all those up, you should get 24. What would that look like in a multiplication sentence? Well, how many 6s do you have? 4 of them. So I have 6s 4 times, and I'm going to get the exact same amount of grapes. And then if we were in school, I know you guys would tell me label. So I would have 24 grapes. Now you might be looking at this going, okay, yeah, that's super easy. Keep this in mind when you try the next problem. Okay, so I hope you tried the drinking water problem. I'm going to show you some ways you could have solved it, and then you compare it to what you did and see if that makes sense. Okay, so the problem said that someone was really tired doing all their workouts they should be doing on the shutdown so they don't get all chubby-wubby, and drank 3/4 a cup of water. If I was modeling this, I'd probably just draw a cup and shade in 3/4 a cup of water. So let's label that. But throughout the day, she repeated this 5 times. So let's just repeat it. One fourth, 2/4, 3/4. 1/4, 2/4, 3/4. 1/4, 2/4, 3/4, and my big old head in the way. Can you see? Okay. 1/4, 2/4, 3/4. So if you didn't model it, that's okay. If you went straight to a repeated addition sentence, that's also fine. But I just wanted you to be able to see where this 3/4 came from. So she drank 3/4 a cup of water, but she repeated this 5 times. And the question just asked for how much water did she drink? So if I was going to turn this into a multiplication sentence, ask yourself, how many 3/4 did we write down? How many times did she repeat 3/4? That's right, 5 times. So I could also write 3/4 times 5. Now I'm not going to write 5 little because that looks like a fraction. I want to make sure, where's my eraser? I want to make sure it's a whole number. So I'm going to make that 5 pretty big. Big 5. And this is not just times it by 5, nothing crazy. I'm literally saying 3/4 5 times. So you could count up your model. You could do the addition. Remember, when we're adding fractions, the denominator does not change because that's what kind of fraction we have. We're just adding our numerators, the numbers on top. Or I can just multiply what's 3/4 5 times. So pause your video and give it a try. Okay, I'm just kind of waiting. Hopefully you paused and you tried it. I'm going to pretend like you paused and unpaused. So if I counted all those up or I multiplied them, you should have got 15/4 cups of water. I'll put C for cups. One small thing, that this is now a fraction greater than 1, or an improper fraction as it's sometimes called. So an extra step would be to change that into a mixed number. We learned that last week, so give that a try. Pause the video, give it a try. Okay, I'm pretend pausing again. Hopefully you paused and you tried it. But what I know is I can take fourths out. 4/4, 4/4, because those are all one whole. There's 1 whole, 2 wholes, 3 wholes, So far I have 12, but I have used 15. So 12, 13, 14, 15. Wait a minute. That's 16 fourths. I can't take another 4 fourths. I can only take out 3 fourths. So that's not one whole. That's a fraction. So let's see how many whole numbers I have. 1, 2, 3 wholes and 3 fourths cups of water. I'm going to show you another way you could solve this in the next part. Okay, another way you could have modeled this problem is just counting 3 fourths into several cups at once, because it, she did drink it separately, but sometimes it makes sense in different kind of problems where you would just keep adding those 3 fourths up until you got to your total. So what I mean by that is, if we know that she drank 3 fourths a cup of water 5 times, I could just draw cups that are split in fourths and then put in 5 3 fourths. I know that sounds weird, but here's what I mean. So I know there's the first time she drank. And I marked it 3 times because each one is 1 fourth. So 1 fourth, 2 fourths, 3 fourths. There's the first time she drank. Then the second time she drank, I'm going to fill in the rest of that because I didn't fill up this whole cup yet. So there's the second time. 1 fourth, 2 fourths, 3 fourths. Now the third time. 1 fourth, 2 fourths, 3 fourths. And I know I have to do this 5 times. 4 fourths. Nope, sorry. 1 fourth, 2 fourths, 3 fourths. And the fifth time. 1 fourth, 2 fourths, 3 fourths. Then I just see how many fourths did I mark or have numbers in. So there's 1 hole there. There's 1 hole there. There's 1 hole there. This one only has 3 fourths of it used. So I have the exact same thing that I had earlier. 1, 2, 3 is 3 holes and 3 fourths cups of water. Just a different way to model it. So on the next screen, I'm going to give you some practice problems to try, and then we'll check them together. See how you did. All right, hopefully you've had a chance to give this problem a try. I'm going to show some various ways you could have solved it. So if we know that Richard is cutting tomatoes in half, then I would just draw some tomatoes, cut them in half. It's not perfect because I'm writing backwards on the camera, but there's some tomatoes. I'm going to count until I have 9 halves. So there's 1 half, 2 halves, 3 halves, 4 halves, 5 halves, 6 halves, 7 halves, 8 halves, 9 halves. So in a multiplication equation, this will look like 1 half times 9, and obviously that is 9 halves. But I don't want to leave it as a fraction greater than 1. I wanted to put it into a mixed number, so I can just see how many holes I have. 1 half plus 1 half is 1 whole. 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 And then I have 1 half left. So 1, 2, 3, 4 holes and 1 half. How'd you do? Let's try another one.